So my name is Dr. Ed Wild. I'm a clinical lecturer in neurology and I work in the Department of Neurodegenerative Disease at the Institute of Neurology in Queen Square. My big research question is to do with Huntington's disease, which is a degenerative hereditary brain illness for which there are no treatments that slow down the disease and there's no cure. So the question is, what can we do to try and make a difference to the progression of Huntington's disease? My personal focus is on measuring the changes that Huntington's disease causes in the brain and in the spinal fluid of people who have the mutation that causes Huntington's disease. And we hope that that will be useful for measuring the success of drugs that are being developed to try and alter the progression of the disease. Well, Huntington's disease affects thousands of people in the UK and many more people are at risk around the world. So there are no treatments that are available now, so everyone who has this mutation is destined to get the disease and will unfortunately suffer over 10 or 20 years debilitating effects of the illness. Anything that we can do to alter that will be incredibly valuable for those people and all of their relatives who are at risk. Each of the children of someone who has the mutation has a 50% risk of having inherited the gene. So there's a huge number of people at risk and a huge number of people who stand to benefit from treatments that can be developed to change their fate. Huntington's is also, because we know the gene that causes it, it's also a model degenerative disease. It's less common than diseases like Alzheimer's, but because we know what gene causes it, we can study with certainty the people who are going to go and get it. And we can identify with some certainty the changes that are due to the mutation. So that gives us the certainty that we need to study the disease in a way that will hopefully be helpful in terms of giving us clues to what causes neurodegeneration in other illnesses like Alzheimer's. So we've been running a study called TRACK-HD, which has been studying Huntington's disease patients and people who have the mutation that causes HD over 4 years now. And we've essentially, through studying them extremely carefully in a manner similar to a clinical trial, but in an observational study, and through doing that and measuring all of these things at the same time point, we've developed a toolkit of biomarkers including MR imaging markers, quantitative motor markers and psychology changes that can be used as endpoints for clinical trials. And that's been a fairly groundbreaking study which has really set the standard for observational studies and biomarker studies in neurodegenerative disease. Right now we're focusing on cerebrospinal fluid or CSF. So we're doing lumbar punctures in our patients and in control subjects to look for biochemical changes which may herald the onset of the disease and may be useful as biomarkers. For instance, for the first time we just managed to quantify the levels of the mutant Huntington protein in spinal fluid. That's never been done before, and that's going to be extremely valuable for forthcoming clinical trials.